Okay, this is 4.4, page 2, and the first problem asks us to find the sine theta and cosine theta, so sine and cosine of an angle, and the angles being a 0-degree angle, pi over 2, at pi, and 3 pi over 2. I'm going to go a little step further. I'm going to look for both sine, cosine, tangent, cosecant, secant, cotangent. So we're going to look at all of them for these because it brings up some good points here. So let's just take sine. Sine, again, we're on the unit circle. All right, so sine is going to be whatever our y values are. So for 0, that would be a 0 radian angle, that would be 0. Okay, at pi over 2, the y value is 1. At pi, the y value is 0. And at 3 pi over 2, the y value is -1. So that's our sine of each of those angles. It's whatever that y value is because we're on the unit circle. Okay, now we'll look at cosine. So cosine is the x, because again, unit circle, our radius is 1, so it's x over radius. X is 1, radius is 1, so 1 and 1. That's 1. And then up here, our x value is 0. And for pi, our x value is -1. For 3 pi over 2, our x value is 0. Okay, so cosine of like pi over 2 is 0 because that's the x value. All right, so tangent, let's look, that gets a little bit different. So tangent is, again, y over x. So if we go to a 0, that would be 0 over 1. So 0 over 1 equals 0. Okay. Now we come up here to pi over 2, though, and that would be 1 over 0. 1 over 0 is undefined. So it's undefined. And we're going to see this when we start graphing it. You're going to see we have asymptotes there. So there is no, you cannot have a tangent of pi over 2. It's undefined. But we come over to pi, and that again is 0 over -1, which would give us 0. And then we come down here to 3 pi over 2. And again, we have the same situation where we have -1 over 0, so it's undefined. All right, and then let's go to cosecant. Cosecant is the inverse, the reciprocal of sine. So if sine of 0 is 0, then the reciprocal of that would be 1 over 0, which 1 over 0 is, again, you guessed it, undefined. Pi over 2, the reciprocal of 1 would be 1 over 1, which is 1. Get back to pi, reciprocal of 0 is 1 over 0, which is undefined. And then 3 pi over 2, the reciprocal of -1 is -1. Secant, that's the reciprocal of cosine. I'll do that in red. So reciprocal of 1 over 1 is 1. Reciprocal of 0, pi over 2. Cosine of pi over 2 is 0. So the reciprocal of that would be 1 over 0, which is undefined. And then a pi would be -1, and then this would be undefined. And then for cotangent, it's the reciprocal of tangent. So again, for right here, the reciprocal of 0 would be undefined. In this case, tangent or cotangent of pi over 2 would be 0 over 1, right? 0 over 1, which is 0. So this is 0. This is undefined. And then this is 0. Okay, zip through here. Let's just quickly. So this says sine of pi over 4. So pi over 4, that is on our unit circle, right? Pi over 4. 1 pi, 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, right here. 7 pi over 4 on the unit circle. And it wants sine. This is root 2 over 2, -√2 over 2. Sine is the y value. So sine of 7 pi over 4 is -√2 over 2. Okay, coming around here, 17 pi over 6 is not on the unit circle. So we need to find the coterminal. So I'm going to subtract 2 pi, and 2 pi and 6 would be 12 pi over 6. That's 2 pi. So this gives me 5 pi over 6, and 5 pi over 6 is on the unit circle. It is over here. So I'm looking at this angle. And in this case, X is negative, so that's negative root 3 over 2 and 1/2. And again, this just emphasizes why it's important to know the unit circle as best as you can. So cosine, this would then be negative root 3 over 2. Okay, tangent of negative 8 pi over 3. Again, not on the unit circle, but if I add 6 pi over 3, which is the same as 2 pi, that gives me negative 2 pi over 3. That's sort of on the unit circle. What I could have done is I probably could have added another 6 pi over 3, so I could have been 12 pi over 3 and got it truly on it, but let's just think about it. Okay, we're here, we're going to go negative 2 pi over 3. That would be, this is our initial side. This would be our theta equals negative 2 pi over 3, which is equal to negative 8 pi over 3. Okay, and in this case, again, knowing our unit circle, okay, this is negative 1/2 and negative root 3 over 2. Okay, so I'm looking for tangent of that though. So tangent theta equals y over x. So that's going to be negative root 3 over 2 over negative 1/2. Okay, they're both negative, so that makes everything positive. So this is going to be root 3 over 2 times 2 over 1. The 2's cancel out, so this is root 3. So tangent of negative 8 pi over 3 is root 3. Okay, cosecant of pi over 2. All right, well, then we just saw that. Here is, this is our pi over 2, right? Which is 0, 1. Cosecant theta equals 1 over sine theta. Okay, sine theta, again, is our y value. So this would be 1 over 1 equals 1. Okay, zipping along here. 4 pi over 3, cosine 4 pi over 3. Again, that's on the unit circle. Here is our 1 pi over 3, 2 pi over 3, 3 pi over 3. I should do this in red. That's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So this is the angle we're looking at. At this point, we have negative 1/2 and negative root 3 over 2. Third quadrant, both positive. Both x and y are negative. And because we know the unit circle, we know that. So cosine is our x value, so this is negative 1/2. Okay, tangent of negative 210 degrees, again, not in the unit circle, so let's add 360 to it. So we have the tangent of 150 degrees, and 150 degrees is on our unit circle. It's right here. Okay, there's 150 degrees. And we should know, hopefully, I've left myself no room, that this is, the x value is negative root 3 over 2, the y value is 1/2. Again, tangent is y over x. So again, we have 1/2 over, I said again, but just 1/2 over negative root 3 over 2. So that's 1/2 times negative 2 over root 3. The 2's cancel out. That gives me negative 1 over root 3. We're going to rationalize it, so multiply the top and bottom by root 3. Negative root 3 over 3. Okay, these we did in class, or this one we did in class, I think just recently. So key things here. Second quadrant, sine theta. Sine theta equals opposite over hypotenuse. So, second quadrant. 3, our y value, right? Y over, I should say y over r, So let's see. So 3, and this is 1. So let's draw something like this. Okay. So we know this is 3. That's our radius, hypotenuse. Our opposite is 1. Okay. We have to find, we need to know what is our x. What's x? So we go x squared plus 1 squared equals 3 squared. X squared plus 1 equals 9. X squared equals 8. X equals square root of 8 equals the square root of 4 times the square root of 2 equals 2 root 2 plus or minus. Okay, which is it though? Is it plus or minus? Well, where are we? Because we're in the third quadrant, right, or second quadrant, our x value is negative. So negative 2 root 2. Negative 2 root 2. And in this case, it just wants us to find the cosine of this angle. This being the angle, by the way, again, from terminal side to x, so that reference angle. So cosine theta equals negative 2 root 2 over 3. It also mentions using the trigonometric identities. In this case, we'll look at that very quickly. One of those identities is cosine squared x plus sine squared x equals 1. All right, well, we know sine theta, sine x, sine theta, whatever. We know it's 1/3. So this is going to be cosine x plus 1/3 squared equals 1. Cosine squared x. And x and theta, whatever, it just represents an angle. Plus 1 over 9 equals 1 equals 8/9. Okay, so I'm going to come over here. I'm going to take the square root of both sides. Cosine x equals square root of 8 over the square root of 9 equals, this is plus or minus. Square root of 8 is 2 root 2 over 3. And going back to the fact that it's in quadrant 2, we know that it is negative 2 root 2 over 3. And what do you know? These two answers are the same. Two different ways of doing it. You will most of the time just want to draw triangles. It typically is easier and it's more visual, whatever, but you can use the trig identities. All right, last one very quickly. Quadrant 3. Hypotenuse is 13, and our y value is negative 5. 13, negative 5. If you don't know already, if you have a right triangle and one side is 5 or negative 5, and the hypotenuse is 13, the other side is 12, special right triangles. And in this case, it would be negative 12 because, again, our x values on our x-axis were negative because we're in the Q3. So this point right here is negative 12, negative 5. Okay, the x and y values. So it wants secant of this angle right here. Okay, secant is negative 12 adjacent over opposite, negative 5. So this is going to be 12/5. I just noticed my key was wrong. Oh, secant. No, I'm sorry. God, I'm wrong right now. I was doing cotangent. Secant is r over x. So that's 13 over negative 12. Ooh, bad mistake. All right, last one is tangent theta. All right, tangent is going to be y over x. So it's going to be negative 5 over negative 12 equals 5/12. All right. Whew, not bad for Friday night. Tired.